Over here is our serial terminal. I write a command called AT plus CMGR equals to 3. Now this will open the third, okay, I write 5. Now this command opens the fifth SMS in my inbox starting from the lowest. I press enter. Now this is the fifth SMS, rec read, and it says Unib. So that is the SMS. This is the date and time. Now I open the next SMS called AT plus C MGR, and whatever the index I opened by default 8th SMS in my inbox, that is in the sim memory. So it will be, this is the SMS I got there. Now what I do is that I open the whole inbox. I write this command AT plus CMGL equals to all. Now this will open my complete inbox. See, here you go. The complete inbox is being opened. See, now it has opened all the SMS found in my inbox. Now what I do is that I delete an SMS. I write AT plus CMGD, and I have to select the index, and for the index I write here delete the 8th SMS. Here you go. The 8th SMS is now deleted. Now I access the 8th SMS. I write AT plus CMGR equals to 8. Now I see what is the 8th SMS. So 8th SMS is gone now. There is no 8th SMS. So this is how you are gonna use access the inbox using Sim800L module. Hello guys, welcome to learning microcontrollers. In this video, I'm gonna show you how we can use a Sim800 module with a USB to TTL device, and then I will show you how you can access the inbox SMS using a serial terminal using your PC or a laptop. So this will give you a direction in how you can program this using any microcontroller. So first of all, we will understand what are the commands and how they are used using a PC. And this will also verify if your Sim800 module is working fine or not. So let's get started. So guys, first of all, this is the Sim800L module, the top view. This one is the bottom view. Now guys, the pin layout, leave the pins on the left. To send and receive an SMS, you only need these pins on the right. The VCC pin, the second from the top, then the reset pin, then RX, TX and ground. Now these three pins, TX, RX and ground, these tell us that this is a UART based protocol. So if you want to interface this with a microcontroller, you will need a UART port in your microcontroller to access it. Very simple. Rest of the pins, you do not need them for sending and receiving an SMS. So in our case, we will be just accessing the inbox, the SMS saved in the memory of your SIM card. So for that, you just need these pins. So now the next thing is, this is your SIM card. Just flip it, put it upside down, then you insert it. You insert it from here. Now guys, this over here is a USB to TTL device. It's already labeled. Let me label it again for you. Now this over here is our Sim800L module. So let me do the labeling for the USB to TTL device. The topmost pin is a 5 volt, then we have VCC, 3.3 volt, TX, RX and ground pin. Now remember, you can use any USB to TTL device available at your place. The great thing is, all the USB to TTL device have 3 pins in common, TX, RX and ground. We only need these 3 pins. Rest of the pins, these are the power pins. Some devices may have only 3.3 volt option, some may have only 5 volt option, some only have VCC. So that doesn't matter, because we are going to power up the Sim800L module from a separate source. So let me re-label the Sim800L module for you as well for connections. So the second from the top pin is the VCC, then we have reset, RX, TX and ground pin. These are the pins over here. Now guys, the next thing is to do the connections and powering up the Sim800L module. Now remember that Sim800L module have a bad habit that it requires a lot of power to work. So once it's in full functionality, it will starve your microcontroller or a USB to TTL's power supply. So remember, you always power it up from a separate source. So separate source must be a 3.7 to 4.4 volt range DC power supply or a battery. But the good thing is, these voltages seem odd, like 3.7 to 4.4 volt range is not common. But the great thing is, your only lithium battery, the LiPo battery or a lithium 1865 cell, whatever you have, they always come in 3.7 volt rating. So this is the rating of a battery. If you have a battery, that's a great option. And batteries always have a lot of current, the rechargeable battery. Just connect it directly to the Sim800L module. So let me show you how to do the connections if you have a battery or a DC power supply. A battery or a DC power supply always have 2 terminals, the positive and the negative. So first of all, for the VCC pin of your Sim800L module, just connect it directly to the positive terminal of the battery like this. Now guys, the ground of your Sim800L module will go to the ground of the USB to TTL device like this. Remember that for the TX, RX and ground pin, they are common in all the USB to TTL device. The recommended one are the FT232, CH340 or CP2012, whatever, any other as well. Now the Sim800L and the USB to TTL device grounds are common. Also common this ground to the negative pin of your DC power supply or the battery. In this way our grounds are connected. Now the Sim800L module is getting powered up from the battery, but we will not connect this positive supply to the USB to TTL device, because once we connect this device into the computer will automatically power up this device. So that's all. You do not need to connect this to anything else. We are just powering up the Sim800L module from the battery, and the USB to TTL device will be powered up from the computer. Simple as that. Now guys, let's do the more connections. We will not need the reset pins. Don't worry, just leave it. So now to connect the RX pin, there is a problem. The problem is that the RX pin of your Sim800L module operates at 3.3 volt. So Sim800L module basically TTL level is LVTTL, that is 3.3 volt level, while most of the microcontrollers like PIC16FH77A operate at 5 volt level. Even Arduino operates at 5 volt level. So Arduino Uno, I mean 80 mega 328P, it operates at 5 volt level. So in that case, if your microcontroller or a USB to TTL device is operating at 5 volt, then you have to protect this pin, else you will burn the RX pin if you connect it directly. Now what you have to do is that you have to connect the 5 volt coming from your microcontroller or a USB to TTL device to a 3.3 volt. So the transmission TX to RX should be 3.3 volt for the Sim800L module. Now to do that, there are various techniques. There is a low voltage level IC also available in the market. But what I am going to use is a voltage divider. We will be using a voltage divider to connect the 5 volt transmission of USB to TTL device to the 3.3 volt. For this, just you need a 10K resistor or 20K resistor. You may use any other resistor as well. You can use the voltage divider formula to make 5 volt to 3.3 volt. Then the next thing is connect the one end of the 20K resistor to the ground like this. Now the one end of the 10K resistor will go to the RX pin of your Sim800L module like this. From the other pin of the 20K resistor, connect to the other pin of the 10K resistor like this. From this point, you will take out your output, and that will go to the TX pin of your USB to TTL device. So we didn't connect the TX pin to the RX pin of our Sim800 module directly, because TX was 5 volt, it was 3.3 volt. So now this voltage divider circuit will convert the 5 volt signal to a 3.3 volt. So it's safe. Now for the TX pin of the Sim800L module, because now we are sending the data from the Sim800L module to a microcontroller or a computer, whatever it is. So that's not an issue. Even if the device operates at 5 volt as well, there is no issue at all, because it's a transmission. So just connect it directly, TX to the RX of the USB to TTL device. In this way our connections are completed. It is very simple and very easy to use. Now let me show you the hardware before we move on to the programming. So guys, this over here is the Sim800L module. You can see that it is blinking, the SIM is inserted, and this was the antenna. It came with the module. It was an IPEX antenna, so I just connected it over here with the IPEX header. And there is a USB to TTL device I am going to use is CP2102. Connections are as shown in the presentation, so no need to worry. And I am powering up the Sim800L module from the DC power source. It is set to 4.3 volt, 3.7 to 4.3 will do fine. And the USB to TTL device gets powered up from the computer automatically. So this is a simple hardware setup. So let me download and install the serial monitor to see how to use the commands. Now guys, for the serial monitor, there are various serial monitors. There is also one in the micro C as well. You can use any, but I have found a new one. Just write in your Google search bar online serial terminal, and this pops up. The first one, the faster serial terminal, that's one that I am using. Click on it, this pops up. Now this is a serial terminal. This is a great feature now. Now it is available online as well. So just you go here and you click on connect to connect your port. Mine is this one, CP2102 comp9. Click on connect. Okay, here you go, it's connected. Now in this bar, write the 80 commands. First write down 80 to see if the Sim800L module is okay. Okay, it shows okay. Now write the ATI to check the firmware. Okay, it's R14. Now to verify that our sim is working or not, write this command 80 plus COPS question mark. Okay, here you go, parktel, it means my sim is detected. Okay, that's great. Now our sim is detected and our module is working fine. Now the next thing is, what I will do is that I will use a command to configure this to a text mode. By default, the by default your Sim800L module is in the PDU mode. To make sure that you get the messages in the response in the human readable form, you have to write this command 80 plus CMGF equals to 1. Now this makes sure that now you are in the text mode. It reported okay. Okay, it's fine. Now we can access our, you can say the inbox. Now to access the inbox, there is a command called 80 plus CMGR. Now let me show you how to use this. Write down 80 plus CMGR equal to 1. Now here you see a message. See, this is, it has opened a message called read message. It is already read and it was sent there. This means that 80 plus, I show you, CMGR equals to 2. Now this is the syntax of the command 80 plus CMGR, and this is the index. Now this is the message number 2 in my inbox. I press enter. See, it shows the message number 2, whatever the message number 2. Now I open the message number 3. Now I am accessing the inbox 80 plus CMGR, but only the problem is, challenges, you have to remember what is the index 3. I press 3. Okay, 3 is something like an add from. Okay, see. Now I write 80 plus CMGR equals to 5. Now this is the command which allows you to access the inbox. See, now if I want to read all the messages, I write 80 plus CMGR equals to inverted commas all. This command will open all the SMS in my inbox. I press enter. Now see, all the SMS have been, okay, there is an error. Okay, it's 80 plus CMGL, not R, equals to all. Remember that. Okay, here you go. All the SMS are being opened. See, now here you go. All the SMS have opened with the command called 80 plus CMGL. Now these are the commands you will use to access the inbox, and there are various other extensions to the 80 plus CMGL command. Now it was I use all, now I use the rec unread. It will only open the unread messages. I write here 80 plus CMGL equals to rec, and then I give space and write unread like this, and I press enter. Now it will only open the unread messages. So rec unread, whatever the unread messages were there, they have been opened, but in my case there were none. I write another extension of this command called 80 plus CMGL equals to, and I write here rec read. Now only open the read messages. Now see, all the read messages are being opened. Now this is my complete inbox with the read messages. So therefore, if you want to just open a specific message, you just use the 80 plus CMG command, and if you want to open the whole inbox at once, use the 80 plus CMGL command. Now there are other commands as well to play with the inbox. You will have them in the data sheet, like 80 plus CMGD. This will delete the SMS with the preferred index. Now I open a SMS, like I write 80 plus CMGR equals to 3. This is the SMS at third index. So this is the SMS. Now I delete it. I write a command called 80 plus CMGD equals to 3. Now see, okay, now it's done. Now I again open the same 80 plus CMGR equals to 3. Now see, the SMS is no longer there. See, it's gone. I have deleted it using the 80 plus CMGD command. So this is how you are going to use these commands. So 80 plus CMGR is a very important command for a microcontroller. Now in my next video, I will show you another command which you will use, like if the message is coming in real time. Now the challenge over here is that we will not know when the latest message is arriving. Now how we are going to get the latest message? Now that is the problem here. So there is another command I will show you in the next video. So stay tuned. In my next lecture, you will have that command. So thank you very much for your time, guys. We'll see you in the next lecture.